In reproductive medicine, we have reached a strange point. We can select a chromosomally normal embryo, grade it as high quality, and transfer it under optimal conditions. And still, nearly half the time it fails to implant. This means that implantation failure may not be explained by the embryo alone. So my question is simple. What is the uterus actually doing during implantation? And are we measuring the right thing? Today, immune assessment in infertility patients often relies on NK cells measured from peripheral blood. But blood NK cells and uterine NK cells are not the same. They live in different places, behave differently, and may have completely different roles. So using blood NK cells to understand embryo implantation is like trying to understand what is happening inside the house by looking only at the street outside. Implantation happens inside the uterus, and my research focuses on the site directly. I hypothesize that uterine NK cells are not passive immune cells waiting at the implantation site. Instead, they are active regulators that help prepare the uterus to accept an embryo. They may guide tissue remodeling, support vascular changes, and communicate with the embryo during the earliest stages of implantation. To study this, I combined mouse models by tracing NK cells, single-cell analysis, and endometrium on a chip platform that allows us to observe NK cell-embryo interactions more directly. Together, these tools allow me to ask, which uterine NK cells matter, what signals they use, and how they shape the implantation microenvironment. If uterine NK cells are active regulators, then my current approach needs to change. We need biomarkers from the uterus itself, not indirect signals from the blood. This could open the way to endometrium-targeted diagnostics and eventually treatments that address implantation failure where it actually occurs. For the Republic of Korea, which faces the world's lowest fertility rate, reducing failed IVF cycles is more than a clinical goal. It means reducing the repeated physical, emotional, and financial burden carried by patients. My research aims to understand how the uterus becomes ready to welcome an embryo and how we can better support that process. Thank you.